All right, here we are back again, still with our mockingbird friend right outside my patio in the background. Um, let's look at the range of a function here. So the range of a function is the set of output values, or y coordinates, that you can get. So it's another way of looking at this, it's the set of numbers k, like actual numbers you could plug in for this k right here, so that this equation where x is the variable has a solution for x. So first, we're going to go back to example 3 to find the ranges of these functions right here. So the ranges are going to be y coordinates that you get. Like the x is the inputs that we got. The y coordinates are going to be the output values. So here you have, at this point, an output value of -1. At this point, you have an output value of 1. Here you have a 3 as the output and 5. So what is the range of f of x? It is the set of numbers, I would kind of call it y equals -1 or 1 or 3 or 5. Now looking at g of x, the range of this function is a set of all these y coordinates. So that starts at -1, and then you have all these y coordinates up to 5. But again, this doesn't include the -1 or the 5. So -0.99 is in the range, 4.9 is in the range, but 5 is not. So g of x here has range. You could write it as y is between -1 and 5, or you could write it as g of x is between -1 and 5. Either way you want to write it here, these mean the same thing because, of course, whether you write it as y or g of x, those mean the same thing because y and g of x are the same on this graph. Okay, so there's three approaches to finding the range of a function. You can analyze the algebraic structure of a formula, and for most of the problems we're going to look at, this is going to be the easiest way. We could, if that doesn't work, you could graph the function. And sometimes this doesn't work very well if it's tricky to get the right window, especially if you're doing it on a TI-83 or TI-84 calculator. Sometimes it's hard to know if you're sure if you're getting all the right features of the graph. You could also do this by actually solving k equals f of x for x in terms of k and seeing what values of k make x undefined. And this is sometimes tricky. And if there's a value of k that makes x undefined, that means that k is not part of the range. But yeah, we'll see why that's tricky sometimes. So let's look at this example A here. So if you want to find the range of this, like what are the possible y coordinates you can get out? That's like saying what are the possible results of doing 3x minus 1 for different numbers of x. You could get a positive number out if x is a big number. If x is something like -10, you're going to get a negative result out. But really, you could get any real number. Could be the result of doing 3 times a number minus 1. So the range is all real numbers. So if we look at this over here, that's going to look like 3x, was it minus 1? Yeah, so y equals 3x minus 1. You can see that any y coordinate that you want to get here is the y coordinate of some point on the graph. Let's look at this one. F of x equals x minus 2 quantity squared plus 3. well, let's think about this. This is a quadratic formula. Sorry, quadratic function. It's not the quadratic formula, negative b plus or minus the square root of yada yada. This is a quadratic function. And it's in vertex form. So let's think, what is the vertex? If the vertex form, just a quick reminder, is f of x equals a times x minus h squared plus k. In this case, the h and the k are 2 and 3. So this has vertex 2, 3, and it opens upwards because it's positive in front. It doesn't have a negative number here. So that means the graph of it is going to have to look something like this. So what are the possible y coordinates that you can get out of these points? It's going to be anything that's 3 or greater. Another way to see this is that x minus 2 squared, if we're just looking at the algebraic structure of this formula, x minus 2 squared is always positive. Or no matter what x is, it's always greater or equal to 0. And then if you add 3 to that, you'll see that x minus 2 squared plus 3 is always greater or equal to 3. So that means no matter what x is, the result, the f of x values are always greater or equal to 3. And that includes 3 here, because you'll get 3 when you plug in x equals 2. So that's the range of that. Here's a weird one. F of z equals z to the power negative 1. Now remember, z to the power negative 1 is another way of writing 1 over z to the power 1, or just 1 over z. So what kinds of output values can you get from this? Well, if you plug in z as a positive number, 1 divided by a positive number is going to be positive. If you plug in a negative number, 1 divided by a negative number will be negative. But you're not allowed to plug in 0. So f of, pen's not working, f of 0 is undefined. So is it possible to get 0 out? Well, let's think. Is it possible to get 0 equals 1 divided by z? Well, if you try to solve this, you could multiply both sides by z. You'll get z times 0 equals 1, or in other words, just 0 equals 1, which has no solution. So it's not possible to get 0 out here. All right, so let's see. If you want to see this on a graph, that's a good way to do it. Write this as f of z equals z to the power negative 1. You could also write it as 1 over z, that works too. And you can see here that all of these y coordinates have a point on the graph that goes with them. All these negative y coordinates here have a point on the graph that goes with them. But there is no point on the graph where the y coordinate is 0. So that means the domain, or sorry, the range of this is everything except 0. So you write f of z is not equal to 0 for that. How about this one? So this g of r is a little bit more complicated looking, but it's a similar idea. So the 2 over r cubed, if we're going to analyze the algebraic structure of this, 2 over r cubed can be anything other than 0. r cubed can be positive or negative depending on if r is positive or negative. But you're never going to get 0 from this part. And then when you do 4 plus that, you're going to get 4 plus anything other than 0. So the result is going to be anything other than 4. So looking at it that way, the range of this is g of r is not equal to 4. And it's a good idea to verify that on a graph. And yeah, so let's see. You can get 0 as an output here if r is negative 0.63. You can get 5 as an output if r is 1, it looks like. But you cannot get 4 as an output. There's no point over here where y is 4, and there's no point over here where y is 4. How about h of x is equal to 8? Well, let's see. No matter what x you plug in, you're going to get 8. If you're going to make a table of this, it would look like so. If you plug in negative 2, the result is going to be 8. If you plug in negative 1, the result is 8, and so on. So what are the h of x output values you get? It's 8. So the range is just 8. Or you could say h of x is equal to 8, and that's fine too. How about this one? This is the square root of t minus 3. Well, let's think. What kind of results do you get from square roots? If you do the square root of negative 1, square root of a negative is undefined. You can do the square root of 0 and get 0. You can do the square root of 1 and get 1, or the square root of 4 and get 2. So the domains of this are all going to be outputs of square roots, and those are always greater than 0. And you can see that with a graph. Let's double check that. Okay, so it looks like this. And looking at the graph here, yeah, what are the y coordinates you get? Zoom out a little bit here so you can see, yeah, if you plug in t equals 3, the result is 0. If you plug in t equals 4, the result is 1. If you plug in t equals 7, the result is 2. But there are no points where the y coordinate is negative. So the the range of this is g of t is greater or equal to 0. All right, up next you have some exercises. I recommend starting by trying to think about the algebraic structure like I was doing. You can always use Desmos to get a good picture of it if you're stuck that way. And so find both the domain and the range of these. Exercise 2 is maybe a little tricky, so if you get stuck with that one, that's okay. Exercise 3 is a little bit weird too. But give these your best shot. The more you struggle with difficult problems, the more you'll learn. It's not always fun, but that's the way to do it. And good luck with that, and I'll see you when I show you the answers in the next video.